Hey everyone, we're doing worksheet number 12b, which is about angle properties of triangles and quadrilateral. This is question number 1. The three angles in a triangle are 5x, 6x and 7x. Find the value of x. So we know from a couple of last years that sum of all angles in a triangle equals 180. So we add these angles and sum them up to 180. This would become 7x, 7 plus 6 plus 5 gives us 18. X equals 180, which makes x equals 10. Part B, work out the size of the largest angle in the triangle. So the largest angle will simply be 7x, which is 7 times 10, which is 70. Question 2. The three angles of a triangle are 2x, 75 degree and x plus 15. Work out the value of x. So simply 2x plus 75 plus x plus 15 equals 180, which gives us 3x plus 80 and 90 equals 180. So this gives us 3x is equals to 90. So x equals 30. Question 3. Use the information in diagram to find the value of A. So this angle would be 55, and you should know this formula. It's a very handy formula. This is called an exterior angle, and these two angles are called opposite interior angle. So there is a formula which connects these two, which is exterior angle is equals to sum of opposite interior angles. So get used to this formula, it makes the working a lot easier. So A is equals to 55 plus 50, so A equals 105. Question number 5. Sorry, question number 4. Just a second, let me grab the pen. Yes, question number 4. The diagram, in the diagram AC and BD are straight lines. Find the value of P and Q. So for P, we need to know that sum of angles on a straight line equals 180. So P plus 48 equals 180. So P equals 132. And for Q, next for Q, let's again use the formula. Exterior angle is equals to sum of opposite interior angle. So exterior angle equals sum of opposite interior angles. So P equals 55 plus Q. So 132 equals 55 plus Q. So to find Q, subtract 132 and 55, and we get 77. Question number 5. The triangle ABC is an isosceles triangle with AB equals BC. CB, angle ABC is 44. Find angle ACB. So it's pretty easy question. In an isosceles triangle, two angles are equal in length and two sides are equal in length and two angles are equal. So these two angles would be equal because they're underneath the two straight lines, two equal lines. So we can use the formula that sum of all angles in a triangle equals 180, and this should give 2x equals 180 minus 44, and then 136 divided by 2, which is 68. Question number 6. One angle of an isosceles triangle is 48 degree. Write down the possible pairs of values for the remaining two angles. So an isosceles triangle is such a triangle whose these two angles are equal, right? So the given 48 angle could be this angle, and then the two lower angles would be equal, x and x. This is one case, and the other case would be that this angle is 48. Then if this angle is 48, then this angle is also 48. And then we need to find the third angle, this one. So in the first case, we can write 48 plus 2x equals 180. So 2x equals 180 minus 48, which is 132. Then x equals 132 over 2, which is 66. So we got two angles in this case, 66 and 66, since both the angles are the same. Okay. Second case is when one angle is unknown and the other two angles are both 48, equals 180. So I'm going to do x equals 180 minus 2 times 48, which gives us 84. So we're getting two angles here. One is 84 and the other one was 48. Question number 7. In the diagram, AB is a straight line. Find the values of x and find the value of y. X is easy, x plus 120. Both these angles lie on a straight line. So sum will be equals to 180, and then 180 minus 120 is 60. Next is find y. So for y, we'll add the three angles and equate it to 180, and we get y equals 40. Question 8. Okay. The diagram shows a quadrilateral. Find the value of x. So sum of all angles in a quadrilateral equals 360. Equate this to 360 and then take all the values to the other side, subtract them from 360. 360 minus 83 minus 72 minus 104 is 101, which is the answer. Question number 9. Question 9. The angles of a quadrilateral are x, x plus 5, 2x minus 25 and x plus 10. Find the value of x. So we know sum of all angles in a quadrilateral equals 360. So add all the given angles, equate it to 360, apply a little algebra and get your answer. So we have 1, 2, 3, 4, 5x plus 5 minus 25 plus 10. 5 minus 25 plus 10, it is minus 10. So minus 10 equals 360. So 5x equals 370 and x equals 370 over 5, which is 74. Next up is question number 10, which says the diagram shows a quadrilateral A, B, C, D. This is a straight line. Calculate the value of x. So if this side is x, then this angle would be 180 minus x, because angles on a sum of all angles on a straight line equals 180. So this would be 180 minus x. Now the sum of these four angles would be 360, because sum of all angles in a quadrilateral equals 360. So we'll simply do 120 plus 73 plus 82 plus 180 minus x equals 360. Let's take x to the other side. It minus x will become plus x, and bring minus 360 to this side. So 120 plus 73 plus 82 plus 180 minus 360. So this is 180. So we have 120 plus 73 plus 82 minus plus 180 minus 360, which gives us 95. Question number 11. The diagram is made from 5 congruent kites. Let me drag it here. The diagram is made from 5 congruent kites. Congruent means that they're exactly identical. So if this is 42, then this would be 42, this would be 42, this would be 42, and so on. And similarly, if this is x, then this is also x, this is also x, x, and x. This is x, and these were 42. Similarly, since they're kites as well, so kite has one line of symmetry, right? So it has this line of symmetry, so this angle equals to this angle. So if this angle is y, then this angle will also be y. So this is y, and so are all other angles. Y, y, and so on. Now what do we need to find in this question? Find x. So to find x, we have 1, 2, 3, 4, 5 angles x degrees, and they're all originating from the center of from a point. So sum of all angles originating from a point equals 360 degree. So x equals 72. Question 11. For part B, find y. So to find y, we can use any one of these kites. If let's consider this kite. Here I have one angle which is x degrees, one angle which is 42 degrees, and two angles of the size y, and sum of all angles in a quadrilateral equals 360, and we already have the value of x, which is 72. Now simply in your calculator do 360 minus 72 minus 42 and divide the answer with 2, and we get 123. Y equals 123. Question number 12, part 1. For the triangle, show that 3a plus 5b equals 170. So we know in a triangle sum of all angles equals 180. So add the three given angles, equate it to 180, and then apply a little algebra, and you should get the required equation. So we get 3a from here plus 5b equals 170. Yes, we got the required equation. Part 2, For the quadrilateral, show that this equation holds true. So for that, again, we know sum of all angles in a quadrilateral equals 360. So simply add these and simplify, apply a little algebra, and you would get this. Alright, it's pretty easy manipulation. Alright, so moving to part 3. Solve these simultaneous equations. So how do we solve these simultaneous equations? One equation is 3a plus 5b equals 170, and the other equation is 9a plus 7b equals 310. So I will be solving this using the elimination method. For that, I would like to change this into -9, and then when I'll add these two equations, I would get 0 here. I would end up eliminating a by adding -9a and +9a. So to change this into -9a, I'll simply multiply this equation with -3. So now this becomes -9a minus 15b equals 170 times -3, 510, -510. And then the second equation remains the same. Now when you'll add these two equations, -9a plus 9a will get cancelled, -15 plus 7 will become -8b equals -510 plus 310 will become -200. So something has gone wrong somewhere. In fact, no, simply divide these two, -200 over -8, and we get 25. To get the value of a, simply substitute b is equals to 25 anywhere over here. So I'll just substitute it in 3a plus 5b equals 170. So 3a plus 5 times 25 equals 170. 3a equals 170 minus 5 times 25 whole divided by 3, so a would come out to be 15. Last part, find the size of the smallest angle in the triangle. So a is 15 and b is 25, and we need to find the smallest value. So I guess that would simply be 2a. So part 4 is simply 2a, which is 30, is the smallest angle. Question number 13. All angles are in degree. The trapezium ABCD has 4 angles as shown. All angles are in degree. Part 1, show that 7x plus 4y is equals to 390. Now we are discussing a trapezium, and for a trapezium we know a couple of properties. That is, if these two lines are parallel, then if this is a and this is b, then a plus b should be equals to 180 because of interior angles. Sum of interior angles equals 180. Similarly, if this angle is, let's say, c and this angle is d, then also c plus d equals 180 because of the same reason. Sum of interior angles equals 180. And also sum of all these 3 angles would be 360 because sum of angles in a quadrilateral equals 360. So we'll be using probably 2 of these properties to show the required equation. So let's see what is asked first. 7x plus 4y is equals to 390. So okay, so for part 1, let's see, do we have to add these two and equate it to 180, or do we add these two and equate it to 180, or do we add these 4 and equate to 360? So let's see what's happening in this question. 7x plus 4y is equals to 390. So 390 is pretty close to 360. So most probably we'll be using sum of these 4 angles equals 360. Let's see. Also by adding 2x and 4x and x, we're getting 7x. So this is our second hint, that we'll be using sum of all angles in a quadrilateral equals 360. So 2x plus 5 plus 3y minus 20 plus 4x minus 5 plus x plus y minus 10 equals 360. This would definitely simplify to this. So I'm just going to write this 7x plus 4y equals 390. Part 1. Part 2, show that 2x plus 3y is equals 195. So again we're either adding these